Hello everyone, welcome back to our second revision session on IGCSE Math 0580 Extended. Today we'll be doing the first half of Unit 2, Algebra. To start algebra, we need to get used to the unknown variable. Algebra has the same rules as arithmetics, but it has one more element, which is the unknown variable. You can see it very common as x or y. You can see an expression like this, x equals 1 plus 2. In arithmetics, we would state it as x plus 2 equals blank, or a question mark. But in algebra, we have a variable for it, and we call it x. In this case, x is 3. But x, or any other letters, or any other representation you like, could represent any values. It can be a variable that varies, or it can be a constant. Another example would be x minus 1 equals 3. In this case, x is with a constant -1. You can solve this by adding 1 on both sides, achieving x equals 4. The same variable in one equation stands for or represent the same value. For example, 2x plus 3 plus 4x equals 10. The x here, even if unknown, stands for the same and only one value. If you want two or more unknown values, you need two or more variables. For example, 2x plus 3y equals 5. In this case, x could be 1, y could be 1, x could be half, 1 could be 3. Now moving on to combining like terms. In expressions, you could see something like 4x plus 2 plus 3x equals x plus 5. You cannot solve this directly because of the x on both sides. And in order to solve this, you have to group all the like terms on one side, which we can do by first adding the x's on one side. 7x plus 2 equals x plus 5. Then move the x to this side and move the 2 to this side. Gives us 6x equals 3, which x equals half. Or something complicated, like this one. So to group this, we'll find a term with the same power. So 2a squared, you can see this like 2 times a times a. So there's 2 a's and 0 b's. And 5a squared is 5 times a times a. So combining these two terms, we'll get 7a squared. Then moving on to 3ab and -9ab. This is 3 times a times b, and this is -9 times a times b, which gives us -6ab. Finally, combining the constant terms, they have 0 a's and 0 b's. Adding them together, we'll have +3. Now move on to expansion. To expand a term with variables, you can do such things. 3x times 2x minus, so plus -4y. So you do time this in the brackets 1 by 1. This gives us 3x times 2x, which is 6x squared, plus 3x times -4y, which is 6x squared, minus 12xy. Now, if you have two terms in the brackets form, when they can combine into one, you just split it and multiply. So 3x plus y times x minus 4y. You times 3x by x, then you times 3x by -4y, then you times y by x, and y by -4y. 3x times x, 3x squared, 3x times -4y, -12yx, y times x plus yx, y times -4y minus 4y squared. Then combining like terms, we'll get 3x squared minus 11xy minus 4y squared. And now do things that's even more complicated. Let's do it here. So in order to do this, we first expand 2 of the 3. So x minus 2 times x plus 3, x times x times 3 plus negative 2 times x plus negative 2 times 3. This is x squared plus 3x minus 2x minus 6, which is x squared plus x minus 6. Then you times the result with the third term. Gives us x squared plus x minus 6 times 2x plus 1. This is 2x times this whole thing plus 1 times this whole thing, which is 2x times x squared minus plus x minus 6 plus 1 times x squared plus x minus 6, which gives us 2x cubed plus 2x squared minus 12x plus x squared plus x minus 6. Combining the like terms, we'll get 2x cubed plus 3x squared minus 11x minus 6. Factorization. Factorization is similar to expansion, but actually the exact opposite. So to factorize an expression, we look at their common factors. For example, 2x cubed plus 2x squared plus 15xy. We can see this as 3 times x plus 3 times 5 times x times 1. We can see that they both have the term 3x. Taking it out, we have 3x, 3 times x, plus 5 times y, which is exactly what happens in the example. A more complicated example could be something like x squared y minus 5xy plus 6x squared minus 30x. Now looking at this, a bit messy, but we can spot that they all contain an x term, so we can take it out. Now we'll have xy minus 4y plus 6x minus 30. And these two terms all have a y, which we can take out a y, makes it y x minus 5 plus 6x minus 30. And then looking at this term here, 6x minus 30, they both contain a 6, makes it 6 times x minus 5, making the whole expression as x times y times x minus 5 plus 6 times x minus 5. And now we can take out 8x minus 5 term, finally factorizing this as x times x minus 5 times y plus 6. Now when you see expressions like x squared plus 6x plus 9, you know that there are only x and it's quadratic. So it must have been something like x plus a times x plus b. Expanding x plus a times x plus b, we'll get x squared plus a plus b x plus ab. So when we're factorizing quadratic expressions, we'll try to think of an a and b that satisfies this situation. In this case, a plus b equals 6, a times b equals 9. We can know that a equals 3 and b equals 3 as one of the solutions. Thus, x squared plus 6x plus 9 equals x plus 3 times x plus 3 equals x plus 3 squared. Now moving on to complete the square. So when we are solving equations like x squared plus 3x plus 4 equals 5, this is pretty hard to solve, but instead we could use complete the square. One way is that when you have something like this, we make all the stuff on one side, leaving it a 0 on the other. We'll have x squared plus 3x minus 1 equals 0. And then we do a thing called complete the square. So we know that a square expansion looks like this: x squared plus 2ax plus a squared. And we're trying to make the expression here into something like this. So starting with the second term, we have 2a equals 3. A equals 3 over 2. And now do expansion like this. But we notice that the constant term a squared should be 9 over 4 instead of -1. So what we'll do here is we do x squared plus 3x plus 9 over 4 and minus 9 over 4, canceling out, keeping it exactly the same, minus 1 here. And we use part here to make it into a square, x plus 3 over 2 squared. And what we're left is negative 9 over 4 minus 1, which is negative 13 over 4. And this is all equal to 0. Then we can solve it by moving the 13 over 4 on one side. X plus 3 over 2 equals plus minus square root 13 over 4. Thus, x equals negative 3 over 2 plus minus square root 13 over 4. And you can see other expressions where x squared has a coefficient, like 2x squared plus 8x minus 5. Here, you'll take out the 2, making it 2x squared plus 4x minus 5. And then do a complete square here. So we know that a is 2 because 2a is 4. Then it will become x plus 2 squared. And we have to add a minus 4 because a squared is 4. Then minus 5. Taking out the 4 by times 2, we'll get 2x plus 2 squared minus 8 minus 5, which is 2 times x plus 2 squared minus 13. Now moving on to algebraic fractions. Algebraic fractions is something like this, and you want to make it one term into a one mixed fractions. You're doing this by making the denominator the same. In the first example, we can achieve this by multiplying 2 for the left fraction and multiplying 3 on the right fraction, which gives us 2x over 6 plus 3x minus 12 over 6. Adding this together, we have 5x minus 12 over 6. Now for the second term, just the same way as the first example. Then we'll have 4x over 6 minus 9 times x minus 5 over 6. Expanding the left fraction and adding them together, we'll have 4x minus 9x plus 45, because negative 9 times negative 5 over 6. Combining like terms, we'll get negative 5x plus 45 over 6. Now moving on to multiplication. Multiplication of fractions with algebras works exactly the same as normal arithmetic multiplication of fractions. So just times the numerator and multiply the denominator. We'll get 27a times a over 40, which is 27a squared over 40. Then moving on to division. Division works also the same as arithmetic divisions. We multiply their reciprocal, which is 3a over 4 times 10 over 9a. This cancels out the a and a 3 and a 2, leaving us 5 over 6. Now moving on to harder examples like this. So what we do is we try to make the denominator the same, and we do this by times the other denominator, which makes this x minus 3 over x minus 2 times x minus 3 plus x minus 2 times x plus 1 over x minus 2 times x minus 3. Expanding this and adding them together, we'll have x minus 3 plus x squared minus 2x plus x minus 2 over expand the bottom. We'll have x squared minus 3x minus 2x plus 6. Combine the like terms, we'll have x squared plus 0x minus 5 over x squared minus 5x plus 6. And now the final term. So we can do this by factorization. We can obviously see that the numerator is x times x minus 2, and the denominator x squared minus 5x plus 6. We already know that this is in the form of x plus a times x plus b, which is x squared plus a plus b times x plus ab. So here, a plus b equals -5 and a times b equals 6. A and b is -2 and -3, giving us x times x minus 2 over x minus 2 times x minus 3, which cancels out the x minus 2, gives us x over x minus 3. Indices. Indices of algebras works exactly the same as arithmetic indices. If you have a times a, you'll get a squared. If you have a squared times a, you'll have a cube. If you have a cube divided by a, you'll have a square. If you have square root a, it is a to the power of half. If you have a squared cube root a, you'll have a to the power of 2 over 3. One thing different is that if you have 3a whole cube, instead of 3a squared, you'll have 3 squared and a squared. And if you have 4a, square root 4a, you'll have square root 4 and square root a, which is 2 times a to the power of half. And like the square rule, if I have 3a to the negative 2, instead of 1 over 3a squared, you'll have 3 over a squared, because the power of 3 is 1. Equations. Algebra is often used in solving equations because a variable can represent the unknown term, and while keeping it unknown, we can do manipulations on it. The first example can obviously see that is 2 because 3x equals 10 minus 4 equals 6, 3x equals 6, x equals 2. And now to more complicated examples, we first have to expand and combine like terms, which is equals 3x plus 21. Combining the like term dx's, we'll have 5x plus 21 equals 5. To one side, we'll have 5x equals negative 16, x equals negative 16 over 5. To solve this, we can just multiply the denominator on two sides. Then we'll have x times 2x plus 1 over 2x plus 1 equals 4 times 2x plus 1. And the 2x plus 1 cancels out, leaving us x equals 4 times 2x plus 1. Expanding the right term, we'll have x equals 8x plus 4. Combining like terms, we'll have negative 7x equals 4, thus x equals 4 over 7. Remember, it's negative. Now, equations with two algebraic fractions. What we do, like combining the denominator, making it into one fraction, we multiply both sides by their combined denominator, which is times x plus 2 times 2x minus 1, 2 over x plus 2 plus x plus 2 times 2x minus 1 times 3 over 2x minus 1 equals 1 times x plus 2 times 2x minus 1. The x plus 2 cancels out for this fraction, and the 2x minus 1 cancels out for this fractions, leaving us 4x minus 2 plus 3x plus 6, expanding the fractions, equals x 2x squared plus 4x minus x minus 2, which is, and combining the like term, we'll have 7x plus 4 equals 2x squared plus 3x minus 2. Moving it all to one side, we'll have 2x squared minus 4x minus 6 equals 0. Taking out the 2 times x squared minus 2x minus 3 equals 0. This is obviously in the x plus a times x plus b form, and a and b here is actually -3 and +1. So the answer, so the roots for the answer for this equation would be x equals 3 or -1. Now the final example, just like the former one, we times both sides by the combine of their denominator. So x plus 2 times x minus 6 times x over x plus 2 equals x plus 2 times x minus 6 times 3 over x minus 6. The x plus 2 cancels out, and the x minus 6 cancels out, leaving x squared minus 6x equals 3x plus 6. Moving the terms all to one side, we'll have x squared minus 9x minus 6 equals 0. And solving this, we'll get the answer. Now, simultaneous equations. In the example, you could see equations like 4x plus 3y equals 11, and x plus y equals 3. There's two ways we can solve it. We'll call this equation 1 and equation 2. The first way is eliminating one of the terms. Doing this, we'll do equation 1 minus 4 times the equation 2, and which is 4x plus 3y minus 4 times x plus y. And remember, because the equations are subtracted, the numbers on the other side of the equal sign are also subtracted, which is 11 minus 4 times 3. Expanding and combining like terms, we'll get 0x, which eliminates one of the variables, minus y equals -1, thus y equals 1. And putting this back into one of the two equations, we'll get x plus 1 equals 3, x equals 2. Another way of doing this is we set x or y on one side and moving all the other variables to the other side. Take equation 2 as example. X plus y equals 3. We can make this x equals 3 minus y, and then substituting the x into equation 1 gives us 4 times 3 minus y plus 3y equals 11. Expanding and combining like terms, 12 minus 4y plus 3y equals 11. 12 minus y equals 11. Y equals 1. Now, sequences. There are two sequences you will be dealing with for this level. One is arithmetic sequence, and the other is geometric sequence. One example for arithmetic sequence is 1, 3, 5, 7, 9. You can see these are all odd numbers, and they have a common difference of 2. They have a common difference of positive 2. So this is term 1 where n equals 1. This is term 2 where n equals 2, n equals 3, and go on. So what can we do if we want to find a single term? Let's say an. What we do is we plus a1 by n minus 1 times d, where d is the common difference. An example is that the term 3, the third term, where n equals 3, is a1, 1, plus 3 minus 1 times 2, which is 1 plus 4, which is 5. And what if we want the sum of the first n terms? Sum of the first n terms of an arithmetic sequence is the first term plus the last term times term count over 2. So if we want the sum of the first 5 terms, we'll have 1 plus 9 over 5 over 2. This gives us 25, and we can check this by adding all these together. 1 plus 9 is 10, 3 plus 7 is 10, and 5. 10 plus 10 plus 5, 25. All makes sense. And now geometric sequence. The simplest geometric sequence is 1, 2, 4, 8, 16, which there's a common ratio of 2 times 2 times 2 times 2. So they have a common ratio R, this is a column, of 2. So if we want to find the term Gn, we'll have G1 So if we want to find the one exact term an, we'll have a1 times ratio r to the power of n minus 1. This is because you can see the third term of the sequence where n equals 3 is a1 times 2 times 2, which is 1 times 2 to the power of 3 minus 1, which is 1 times 2 squared, which is 4. Now if you want the sum of the first n terms of a geometric sequence, the formula is a1 times 1 minus r to the power of n over 1 minus r. We can validate this by examining it with the first 5 terms. a1 is 1, 1 minus common ratio r, 2, to the power of n, which is 5, over 1 minus r, which is 1 minus 2. And this is 1 times 1 minus 32 over 1 minus 2, which is negative 31 over 2, negative 1, which is 31. And we're adding these together. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15, 15 plus 16 is 31. And that's the first half of Unit 2.